In this video, I wanted to have a look at all the different types of curves that we've looked at over previous videos and have a look at how you can recognize them from their equations. So the first type of curve that we looked at were parabolas. Parabolas have an equation that looks something like y equals ax squared plus b. Now, parabolas, you can recognize if it's a parabola because it has a y and it has an x squared term in there. Now, what can we tell from this equation? This coefficient of the x squared term, that a, tells us both the concavity and the steepness of our graph. So from that, the bigger a is, so the bigger the value of a, that means our graph is steeper. If a is close to 0, that means our graph is flatter. So our curve is flatter. Now if a is a positive number, so greater than 0, that means our parabola is concave up. And if a is a negative number, so it's less than 0, then our parabola is concave down. So that's what this number at the front tells us. This term on the end, that constant term, tells us the y-intercept of the graph. So if that was, say, a +2, then our parabola is going to have its vertex at +2. If it was like -100, then the parabola is going to have its vertex at -100. So that tells us our y-intercept. The next type of curve that we looked at were cubics. So the equation of a cubic looks something like y equals ax to the power of 3 plus b. So cubics have a cubed x in there, so x cubed. Now, what the variables do in here is very similar to what they did for a parabola. So that term there, again, tells us its steepness, and it also tells us whether it's an increasing or a decreasing cubic. So I won't write it down again, but it's the same. If a is a really big number, then our cubic is going to be really steep. If a is a number that's closer to 0, so a small number, then our cubic is going to be a little bit flatter. So again, if a is greater than 0, then our cubic is going to look something like this. So that's an increasing cubic. As we move to the right, it's getting bigger. If a is less than 0, so it's a negative number out the front, so a negative coefficient of that x cubed term, then our cubic is going to be a decreasing curve. So as we move to the right, it's getting smaller. This constant term on the end, again, tells us the y-intercept of the curve. So it shifts that whole cubic up or down our axis. All right, the next one we're hyperbolas. So hyperbolas have an equation that looks something like y equals a over x plus b. So in a hyperbola, that x has to be in the denominator. So that's how you can recognize it, is if you've got a fraction with the x in the bottom. All right, that a term, so that coefficient of the 1 on x term, again tells us how steep our graph is, but it also tells us which quadrants it's in. So it tells us whether it's increasing or decreasing. So again, if a is big, the graph is steeper. If a is close to 0, it's a little bit flatter. In this one, if a is greater than 0, then our hyperbola is going to be in these two quadrants here. And as we move to the right, it's getting smaller. So that's actually decreasing. So it's a little bit different to the ones we've looked at earlier. If a was positive, it was increasing before. With hyperbolas, if a is positive, if that first term is positive, then our hyperbola is actually decreasing. If a is less than 0, if a is negative, it flips our hyperbola around into these two quadrants. And you see, as we move to the right, our hyperbola increases. So that one's a little bit different to the ones we've looked at before. The other important thing about hyperbolas is that there are two distinct parts to that graph. So hyperbolas have two asymptotes. So asymptotes are lines that the hyperbola approaches but never actually touches. So there's two, one vertical and one horizontal. So they go down here and across here. So that's for your standard hyperbola. I'll just write the spelling of that as well. All right, But if we have this plus b term, that's going to shift our graph up or down. So instead of having our asymptote running along that axis, our vertical one's going to stay the same. But if we had, say, a +2 there, then our asymptote is going to shift up to 2 there. And our hyperbola would be up here and down here. So it shifts everything up or down the graph. The last type of curves that we looked at were exponentials. So they have equations in the form, no, my pen's not working, there we go, y equals b outside of a to the power of x. So you can recognize exponentials because of that power, the x is in the power. So we've got two variables here. Our a tells us the steepness of our graph, and again it tells us whether it's increasing or decreasing. So if a is greater than 1, our exponential curve is increasing. So we'll start near that x-axis and it'll increase as you move to the right. If a is less than 1, but still greater than 0, then our curve is going to be decreasing, so coming down as we move to the right. That b term tells us the y-intercept. So in your standard exponential function, if it's just like 2 to the power of x or 10 to the power of x, and there's no number multiplied out the front, then it's going to cut through, have a y-intercept of 1. If we have something else though, that's going to shift it. So if we had, say, y equals 5 times 2 to the x, then it's going to have a y-intercept of 5 instead. So that would look something like this. Alright, so that's just a really brief overview of all the types of curves that we looked at. So you can hopefully look at an equation and identify what sort of curve it could be and be able to sketch it.